Okay, part 1. Same stuff, but let's analyze and look a little more closely at, is that the definition of analyze? Special triangles, exact values. We've been doing this already. Okay, what do you think of when you hear the word exact? Sorry, Jake? Fraction? Okay, but we've been doing ones, what have they been in the questions? We've had what? Reese? Radicals. Good. Okay. Investigation. This is a 45-degree angle. Okay, what are we doing again? Special triangles. Let's look at the first one. Okay, it's an investigation. It's like a mini lab. Okay? There's a triangle. There's 45 degrees. What's the tangent ratio of this thing? Hands, please. Dannon? Oh, it curved. That's Dannon's. Yeah. Tangent is, here's the angle, O over A. 1 over 1 is 1. Okay? That's a 45-degree angle. That's an isosceles triangle. All right? So use SOHCAHTOA or the XYR. If you've memorized those, great, but it doesn't take very long to draw our little triangle. What's the sine of 45? What's the ratio for sine? Hands? You already got one. Don't bother putting your hand up again. Isn't that Dannon's? How come you're eating it? Carmen? What's the ratio for sine? God, you're bright. Okay, there it is right there. That's SOHCAHTOA. That's all we're doing. So sine, I need opposite 1 over, what? The hypotenuse. I don't have it. Who can do that in their head real quick? What is hypotenuse here? If you already had your hand up, don't put it up again. Dannon? Will? Exactly, it's... Okay. Root 2. Okay, now anybody don't know how he got that? Or do we want me to do that?
I don't know how he got that.
Okay, Pythagoras. C squared, that's always the hypotenuse, it's always the longest side, it's always a side opposite the right angle, is A squared plus B squared. So C, well, if this is a unit circle, that could be called a radius, so let's do that. R squared is 1 squared plus 1 squared. What's the square of 1? 1. R squared is 2. So R is root 2. Okay? So sine is 1 over root 2. Who sees what the cosine ratio is quickly? Shoni? Hey, I could do this all day. Okay. But if that was an answer in the book, Jake, it would be what? Yeah, how did he do that so fast? Wait, let's reward him first. Okay. Let's focus. I know there's treats flying, but let's focus. I want to rationalize the denominator, so I'm going to multiply it by itself. I can't just do that. Whatever you do to the bottom, you can do to the top. Why can I do that again? What am I multiplying 1 over root 2 by? In essence, what am I multiplying it by? Meryl? 1. Because what's root 2 divided by root 2? It's just 1. Okay? But now I rationalize the denominator. What's root 2 times root 2? Hands? Brenna? 2. Sorry, I'm not choosing. I'm just grabbing, guys. Okay? So, trade with your friends. Okay? That's just 2. On the top, I have root 2 times 1. That's how he got that. Okay? So this thing, I could write that like that too. Okay? Tangent of 45, we already said it. What is it again, Tamaya?
Wait, what?
You can't put your hand up before you know the question.
Sorry.
What's the tangent of 45 degrees? Which is? What's 1 divided by 1? Oh, sorry. The M&Ms aren't as aerodynamic. Okay, 1 over 1, which is 1. Yeah, I did. What's this number right here, Brianna? Oh, good. Okay, that's a special triangle. Note what the ratios are. Not as a decimal, exactly. Okay? What do we notice when we have 45 degrees? Are a couple of these the same? Which two? Hands? You already got one, don't put your hand up again. Really, guys? You don't like candy? Okay. Well, sine and cosine, of course, are the same. They're both the same value. Because the opposite's the same as the adjacent, right? Okay. Let's look at 60. We can do this by doing some kind of special triangle. What kind of a triangle is this, where this is 2, and this is 2? Who's got hands? You already got one. Dan? Make it aerodynamic. Okay. So let's split this guy in half. If I cut half, what's half of 2? Hands? Cassidy? Yeah. Okay, so don't look at this side anymore. I just want to look at this triangle. Do I know the sine ratio? Do I know the sine ratio? No. I don't know the height of this triangle or the opposite. How do I find that? 2 squared minus 1 squared is, let's call it height squared. What's that? Who's got it? Who's quick? I shouldn't see any calculators out there. Loyal? Jake, you already got one. Stop putting your hand up.
Oh, that's 8 or 1.
Okay, what's 4 take away 1? 3. That's h squared. What's h? Root 3. Okay, so my sine ratio then is what over what? Hands. Tanner? Yeah, you guys are smart. Okay, cosine ratio is what over what? A over h, which is 1/2. So the tangent, I gotta speed it up a bit, is O over A. But I don't have to put the 1, it's just root 3, right? All right. Special triangle, 60 degrees. If I flip this thing, well, first of all, who knows what that angle is? Hands? Don't yell it out. Allie? I don't reward incorrect answers. That's 90. I'll give you a second chance, though. That's 90, that's 60, this must be. You already said that, and I said no. You don't say it again. Yeah, they got to add up to 180, right? That's 30 degrees. Okay. If I flip this triangle, and put the 30-degree down here, is it going to look like this one? There it is. Yeah, that's the same triangle. I just flipped it over, so 30 is where the 60 is. Okay, there it is. There's 90, 30, 60, 90, 30, 60. Okay, so this length is still 2. What is this length here? Who's got good visual skills? Hands. Griffin. Do you like candy? I want to know what this length is. I got my 3 sides here. I only got 2 candies on this table. It is 1, yeah. Okay, there's 60, there's 90, the distance is 1. This is 60, there's 90, the distance is 1. Okay, now I could do the same thing. I could go 2 squared minus 1 squared is h squared. This is an h now, this is this, but I'm going to get the same answer, aren't I? Okay, root 3. So there's my 3 sides. I can get any ratio I please for 30 degrees. Who remembered what sine of 30 was? Hands, don't yell it out. Anybody who didn't have a hand up already? No? Kerne? Sine of 30? Loyal? Thomas? Caitlin? Okay. Let's make a mental note. Is that the same as one I've already found for 60 degrees?
Yeah.
Hey, look at that. Anyone want to take a guess? Now don't look here, don't cheat. What do you think cosine 30 is, knowing that this relationship? Anyone want to take a guess? Tanner?
3 over 2.
3 over 2?
Or root 3 over 2.
Yeah, good guess. Okay, now let's look. Cosine of 30 is adjacent over hypotenuse. Kind of looks like that one, doesn't it? Okay. Complementary angles, aren't they? These add up to 90, these add up to 90. This one's a little bit different. Tan of 30 is O over A, or Tyrannosaurus Rex. Tan is Y over X. Okay, if that works, use it. If not, don't. Okay, it's just the inverse of this one, isn't it? Okay. Okay, there's 3 special triangles. Let's not put them here, because we'll just be writing them twice. Let's put them in this table on page 169. Okay, what's the sine of 30? Anybody got it? The cosine of what is also a half? What's the sine of 60? Root 3 over 2. Okay, the cosine of what is also root 3 over 2? What is the sine of 45? That was the first one we did. 1 over root 2. What's the cosine of 45? The same thing. 1 over root 2, or root 2 over 2. Okay? Yeah, actually, let's write that one. Okay? Well, let's be consistent. They're both equal decimals. They're both the same number, but we're going to argue this one is more simplified than the other one because the denominator's rationalized. So yeah, let's write it like that. if there's a radical there or not. Yeah, yeah, top's fine. Okay? All right, tangent. What's tan of all this stuff? This is the different one. Tan of 45 is 1. Tan of 60 is root 3. And tan of 30 is 1 over root 3. Okay? 1 root 3 and 1 over root 3. Okay? We should actually rationalize this one now, though, shouldn't we? Okay? Times top and bottom by root 3, and that's root 3 over root 3 times root 3 is 3. Okay? So let's go back and look at this. What about 0 and 90? You played around with it a bit yesterday. Okay? Sine of 0. Well, if this is an angle, there's theta. If I shrink this down to 0, what happens with my opposite? Because this is the ratio. If this thing gets squished down to 0, there's 0 degrees. Right? What's my opposite? Yeah. What's 0 divided by anything? 0. If you see that, great. And if not, well, put sine of 0 in your calculator. It'll say 0. Cosine of 0. If this thing gets shrunken down, the angle gets, like, here's 1 degree, right? If that thing's 0, this is the length of my adjacent, but it's also the length of my hypotenuse or radius. Since cosine is a over h, and these are the same, what's the cosine of 0? What's anything divided by itself? Yeah. Again, if you don't believe me, put it in your calculator. Okay? Cosine of 0 is 1. Tan of 0 is opposite over adjacent, but what's the opposite if this is 0 degrees? Nothing. 0. 0 divided by anything is 0. Now let's look at the other extreme. If this thing gets bigger and bigger and bigger, there's theta, right? What if it's straight up and down? What if my opposite is the same length as my hypotenuse for sine ratio? Then what's the sine of 90? Yeah, this over itself. There's the opposite. There's the hypotenuse. It's the same length, so it's 1. Cosine of 90, if this thing gets bigger and bigger and bigger, and adjacent gets smaller and smaller and smaller, what happens when I get that? What happened with my adjacent? 0. 0 divided by anything is 0. Don't believe me? Put it in your calculator. Now tangent is the weird one. Tangent is opposite over adjacent. Okay, let's say my opposite was 1, but my adjacent shrunk to nothing. How many times does 0 go in 1? We don't know. When I was your age, we would have said infinity. It goes in there an infinite amount of times. Someone didn't like that, so now we say the word undefined. We don't know how many times 0 goes in anything. Okay? You don't believe me? Put it on your calculator. It'll say error. Right? Okay, so now we can put these values in our table. What's the sine of 0? 0. You notice how sine gets bigger and bigger and bigger? This is 0.5. That's bigger than 0.5. That's still bigger than 0.5. And then we get up to 1. Think about it. As theta goes from 0 and bigger, the opposite side gets bigger and bigger and bigger until it's the same size as the hypotenuse. Cosine, on the other hand, gets smaller and smaller and smaller until it's 0. Okay, tangent. You might not know this yet, but do you know tangent is sine over cosine? Okay, if you don't, well, then now you do. It's a ratio of ratios. You can think of it that way. But it goes 0, this, then 1, then that, and then undefined. Okay, so tangent's the oddball, but it's just sine over cosine. Well, what does this say, guys? Should. I'm not going to make you, because, you know, in years past, if I say, okay, guys, we're going to have a quiz, this has to be memorized. I find a couple of these written on the desks when kids leave. I find it inside their calculators when they return them to the library the next year. Okay, I'm not a big believer in memorizing. It's pretty easy to make these, but this is more grade 12, okay? You should be able to make any of these triangles. In grade 12, you will know how to do that. All I'm going to say is, I think a lot of you are taking Math 12. The better you know this, the easier it's going to be next time you take that course. Okay? We should know them. There's a pattern. Okay, this is the same as that. This is the same as this. These are the same for 45 degrees. Okay? If not, we should be able to figure it out pretty quick. Okay? Should be memorized. It'll make your life easier. Okay? All right, a couple of examples, and you're on your own. With this table, and cast, and reference angles, let's put them all together now. Okay, determine the exact values of trig ratios of certain angles in certain quadrants. Okay, because we're not going to give you quadrant 1. That's grade 10, right? Okay, we're going to give you something somewhere else. What is this in terms of a reference angle, but not as a decimal? We want the exact value. So every one of these are going to come down to a reference angle of 30, 45, 60, or maybe 0 or 90. Okay? That's what we just told you. So 210. First thing you should do, draw a picture. Where's that? Over there. How do I find a reference angle in quadrant 3? Subtract it from 180, and that's a reference angle of 30 degrees, right? That's the shortest distance to the x-axis. That's an acute angle. Sine. Is that positive or negative in quadrant 3? Yeah. So do your cast thing. Okay. I know sine, they're all positive here, and sine's positive there. So here it's negative and negative. Here it's negative. Okay, so this is negative sine of 30 degrees. But as an exact value, okay, what is sine of 30? And if you don't have that one yet, have a look. Sine of 30 is a half. So this is negative 1/2. Okay. Now we could double check. What's the sine of 210? Whoop, not in radians. Yeah, you don't use radians till grade 12. But yours won't change. Mine, every time I turn it on, it's like I change the batteries. It's not a real calculator, it's a program, right? So yours will stay in degrees unless someone changes it or you change the batteries. Is that negative 1/2? Okay, we can check it, okay, but we got to know how to do this without technology. Cosine 300, where's that? That's over here. Let's be consistent with yesterday. In this quadrant, is cosine positive or negative? Yeah, cosine is positive, quadrant here. So that's the same as cosine, what's my reference angle? Yeah, subtract it from 360 in quadrant 4, that's 60 degrees. But what's an exact value for cosine 60? Who's got it? Okay. And you're going to want to flip back and forth. Here's your table. You're going to keep looking here, okay? Tan 225. Where is that? There's 180, 225. That's in here somewhere. In quadrant 3, that's 45 degrees. Subtract it from 180. Is tangent positive or negative over there? Positive here. It's all of them are positive here. Yeah, it's positive. Okay? So that's the same as positive tan 45. But do I know exact value for tan 45? It's 1. Can you check that on your calculator? Okay. Bingo. Okay. As a reference angle, the exact value, that's what we're doing. Without technology, that means a calculator. How do you think they did this before they invented calculators, guys? Yeah, but what did they do in math before calculators? The period after the slide rule and before the calculator, you had charts. You had tables, right? Every sine, cosine, tangent ratio, you can print out a little chart and just cross-reference, and there it is, right? It's like a tax table. Okay, determine the exact value. Here's where literacy comes in. What's that say? Yeah, value or values, that means more than one. Okay? Notice this, I might have more than one answer. Because one of you was asking me yesterday, well, how do you know if we're looking for 1 or 2 or 3 things? That tells us. Okay? All of them in between all 4 quadrants here. From 0 to 360. Okay? So, cosine, first of all, what's that? Root 3 over 2. Was that a special angle? Cosine root 3 over 2. Hey, that's 30 degrees. Okay? Okay, where is cosine negative? P-A-S-T. Cosine is negative. It's positive here. It's positive there. So it's negative here. It's negative there. So there's a choice. There's a choice. Okay, that's all my options from 0 to 360. Okay, quadrants 2 and 3. So what is this? What is the exact value of theta? What is theta here? What's the rotation angle? Okay, in quadrant 2, subtract, and that's 150 degrees. In quadrant 3, I add, and that's 210 degrees. So I have 2 answers. Okay? Where's tan undefined? Yeah, I know, you know, but let's have a look. Other people, 10, 90, there it is. Okay? That's 90 degrees, but I might have a couple of options. Tan is 90 degrees. Where is this undefined? Okay? And it's a tricky one, right? What's the sign here? All right, I can look at every quadrant. My reference angle is 90. Okay, but let's check quadrant 2. You can do this method. Well, in quadrant 2, I subtract from 180, and well, I get the same thing. So I still only have one answer. In quadrant 3, I add 90, okay, and that gives me 270. So that's an option. Let's check quadrant 4. I'm going to subtract anything in quadrant 4. You subtract from 360, and I get the same thing again. So I checked all 4 quadrants. Okay, there's no sign here. It's not just restricted to the positives. It's positive or negative. It's one way to approach this. Okay, but I only have 2 answers, right? 90 and 270. Well, let's double check. What's tan of 90? I'm kind of new at this, so I'm still not... Oh, yep, that's undefined. Okay, what's the tan of 270? Whoop. Yeah, that's undefined too. Okay, 2 answers here. All right, so that one I know it's kind of weird because it's right on the 90. Okay, and then we only had 2 examples, but okay. This one's just a little bit different. There's a point. It's a point P. What's the first thing we should do? Yeah, and it's actually asking us to do it anyway. This is A, B, C. On the test, it'll just be one question, right? It'll just be that. Here, we're kind of leading you through it. Draw the angle in standard position and mark the point P on the terminal arm. Well, this is a point. These are coordinates, right? That's just X. That's just Y. What quadrant is this in? X is -3. Y is positive √3. There it is. There's point P. It's in quadrant 2. It must be, because I go negative then positive, right? And if we're really good and we kind of know what √3 is in our head, like 1.7-ish, then we can even make it look a little more accurate, okay? But that's fine. All right? There's my terminal arm in standard position. That's how many degrees I went from the initial arm. We always start here, remember? And rotated it, okay? There it is. I did A. Draw it, mark the point P on the terminal arm. Okay? B. State the values of X and Y. What's X here? Down? All right. Okay. What's Y? Sorry? Well, that's pretty aerodynamic. So, it looks like a saucer. I'll throw it like one. Oh, sorry. Okay. Hence, doesn't that sound like a Shakespearean? Hence. What's tan theta? Tan theta is O over A or Y over X. Tyrannosaurus Rex. What's Y? Well, we just got it. Okay, what's X? -3. Is that the same as -√3 over 3? Sure. Okay. Is that the same as -√3 over 3? Yeah. You don't really, it's already rationalized. It's simplified. That's what it is. Okay. So, what's the reference angle? What is my reference angle? Well, how do I know what this angle is? What is this? What's √3 over 3? What angle are we talking about? 30 degrees. Okay. I know. Now that's not the rotation angle. That's what this angle is. What's the reference angle here? Is that a 35? 30 degrees. Okay? That's what it is. That's why we're asking you to do this. What's the rotation angle? Well, let's draw it again. If that's 30, what's this? What's 180 minus 30? 150 degrees. Caitlin, what's the reference angle? Oh, good. Oh, it's not. Sorry. Yeah, it looks like it, doesn't it? I was, yeah, okay, equals. It was half of an equals. Let's go with that. Okay? All right, that's it. 1 to 5. Part 1.